9 sample test. So we got to find what x, y, and z are. And this is a 90-degree angle, so we can use SOHCAHTOA on this one. You can also use law of sines or cosines, but let's just do that. So x is, and I know this side, and so if I was going for x first, this would be the adjacent. This is the opposite of the angle 23. We never use this when we're using SOHCAHTOA. And so the adjacent and the opposite are related to the tangent. So the tangent of 23 degrees is opposite over adjacent. And to solve this, I'll multiply by x and divide by the tangent of 23, and I'll get x equals 4 divided by the tangent of 23 degrees, which is, pulling out the calculator here, making sure the mode is in degrees, and so I got clear 4 divided by the tangent of 23, and I get x is 9.423. And y is pretty easy. The angles of a triangle add up to 180, or if you have a right triangle, the two left are complement. They add up to 90, so 23 from 90 is 67 degrees. And z, that's the hypotenuse, and if I use my original 23 in case that's a mistake, that's the hypotenuse, and that's the opposite, and sine of the angle is opposite over the hypotenuse. So I'd have to multiply both sides by z and divide by sine of 23, and so z would be 4 divided by the sine of 23 degrees. So I'll just go back in here and make the tangent become sine, and I get the hypotenuse to be 10.237. Okay, there's 1. And now let's go to 2. Now 2, if I want to find x, let's see. Now, I don't have a right triangle, but x, I got 2 of the 3 angles, so I take these from 180 to get this. So 132 from 180 is 48 degrees. I got all the angles and one side. So that looks like it's set up to do law of sines, which is, if I want to get y over the sine of the angle opposite equals any other side, which I know is 30, is the one I know, over the sine of the angle opposite, which is 32 degrees. So to solve for y, I'd multiply by the sine of 100. So I'd have 30 times the sine of 100 divided by the sine of 32. And I get y to be 55.752. And z is opposite this one, so z over the sine of the angle opposite it equals any other side, and the one I knew, so might as well use it, over the sine of 32. And so this is going to be, z is just going to be the same thing, only instead of 100 degrees, I'm going to use the, in place of the 100, I'm going to use the 48. Wasn't that what it was? Yes, 48. And I get z to be 42.071. Yeah. Okay. Just checking, looking to make sure my answers look reasonable. Okay. Number 3. Now I have 3 sides. No, I have 2 sides and an angle. Angle, side, side. Ooh, angle, side, side. There might be 2 answers on this. Up here I had angle, angle, side. There's only going to be 1 answer. Here I had angle, angle, side. So there's only going to be 1 answer. But if I have angle, side, side, there possibly could be 2 answers. Now, I can use the law of sines, and so let's do that because I got an angle and the side opposite, and I got a side opposite, so I would be finding z if I use the law of sines. So the sine of angle z over the side opposite equals the sine of any other angle. And I know the 50 over the side opposite, which is 7. And so I would multiply by 11 on both sides. And then take the sine inverse. So I would have sine of 50 times 11 divided by 7. And then I take the sine inverse. Ooh. How do I do this? Wait a minute. Sine of 50 over side 7 and a sine of z over 11. So did I do the sine of 50 times 11 divided by 7, and the sine of z can't be greater than 1, so this triangle must not be possible. Why is that? So let's make a little sketch just to kind of prove to ourselves. So I've got a side here and a side of 11 that's going 50 degrees from it. So 50 is more than a 45. So that would be something like this. And I want to go 11. So if I count off, make this be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Guess what? 7 is not going to reach this side. So this triangle is not possible. Now, just for review purposes, let's talk about this. What if this was larger, like maybe 10? Then I would have a 10 down here, and when I did this problem on here, if I had a 10 right there, then I get this. That would be what the sine of z is, and then I would take the sine inverse of that, and I would get 57 degrees would be across from z, 57.4 degrees. But is that the only possibility? Well, 10 could fit in here or here. 57 would be this one. But what would be the other option? Well, that would be 57 here, so in the triangle would be 180 minus the 57, minus that that answer. So 122. So I'd have a triangle with 122 and these sides and have to figure out y and z from that, or I have to do it with 57. But for the problem I had on this sample test, it's not even a possible triangle. Now let's go to this one, number 4. Let's see if this one is possible. 7, 8, 9. So I got 3 sides. Well, to get an angle then, law of cosine says c squared equals a squared plus b squared minus 2ab cosine of angle c. So let's say I want to find x. Then that would be what I put here for this, and then c would be the side across. This would be the 9, and 7, and 8, and 7, and 8. So if I brought all of this over to this side and brought the c squared over there, I'd have 7 squared plus 8 squared minus 9 squared equals plus 2 times 7 times 8 times the cosine of x. So if I multiplied these out and divided on both sides by that, so 7 times 8 is 56, times 2 is 112. Just prove that. Make sure I'm right. 2 times 7 times 8. And then we would have 49 plus 64 minus 81 over 112. And that's what the cosine of x is. And so I'd have to do the cosine inverse to get x to be, whoop, did that off the page again, sorry. So then I would do cosine inverse of the numerator, which is 49 plus 64 minus 81, divided by 112, and I get x is 73.3940 degrees. So I got x. And I can do the same process for the other ones. I'm going to pull up the program, cosine law, and use 1 for degrees, and use side, side, side. And if I want to find y, the opposite side is 8. The adjacent side is 7 and 9. And I get y to be 58.4. I got x to be 73.4. And z would be, run this again, degrees, 2 for side, 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 and the opposite side is 7. The adjacent side is 9 and 8, and I get 48.2 degrees. Okay? Number 5. Determine the area in triangle 4. Okay, well, I can get the area by doing the formula. Let's put this over here. Is 1/2 a side times another side times the sine of the angle in between. Those two sides. Okay, so if I bring this down at number 4, there we go. Let's just say I use this angle. So I have the sine of 48.2, and then it has to be the sides that are on either side of that. So that's 9 and 8 and times a half. So 9 times 8 is 72. Half of that is 36 sine of 48.2 degrees. 36 sine of 48.2 degrees is, area is going to be 26.84 square units. Six, find the area of triangle AB. Ooh, C is gone. Well, it's a triangle, so it can't be, let's see. So C, let's put C there. I think that's what I meant to do, and I think it just got chopped off. Okay. Well, I only have 2 angles in that, so I can't do it unless I get some sides. But I have side, angle, side, so I should be able to figure out this side using the law of cosines. And so if I were doing that, I'd be doing, if I called that x, x squared equals 7 squared plus 11 squared minus 2 times 7 times 11 times the cosine of 68 degrees. Take the square root, and I'll know this side. But and that's what the formula does. So law of cosines in degrees, and side angle side is 1, and the angle is 68. The adjacent side is 7. The other one is 11. And I get x to be 10.598. Well, the area, I need to know all 3 sides or 2 sides and the angle between. Well, I don't have that yet. So now let's get this angle. So 20 and 60 is 80, so that means this one must be 100. Because all the angles are 180. And so I can find another side. Let's say I decide to find this one. And so I would use the law of sines, because I have an angle side opposite and an angle side opposite. So let's just do the law of sines program. Law of sines, I did them earlier, so you should know how to do that. Degrees, and so I'm going to try to find this one, but I'm going to use this angle and this angle and this side. So I got angle, angle, side. Angle, angle, side is 1. Good thing there's only one answer. The side that I know is the 10.598. The angle opposite is the 100. And the other angle that I want is 20, so I get the side opposite to be 3.681. So now, to find the area of this triangle, I've got to do 1/2 times the side, 3.681 times another side, 10.598 times the sine of the angle in between. And so I have 0.5, half, times 3.681 times 10.598 times the sine of the angle between 60, and I'm still in degrees, so that should work. The area is 16.8, oh, sorry, dang it, 16.892 square units. Now, I could have found all 3 sides and then used Heron's formula too. Okay. A plane is flying in a straight line with two spots on the ground that are 14 miles apart. So here, let's make that be the plane P, and there's two spots on the ground that are 14 miles apart, and the angle of depression to the one in front of the plane, let's say the plane's flying this way, so in front, the angle of depression is how much from horizontal looking down, is 27 degrees. And to the one behind the plane is the angle of depression is 33 degrees to the other one. And those two planes are 14 miles apart. And it says determine the elevation of the plane above the ground. So we want to know this. So if this is 33, this has to be 90 minus 33, or 57. And 27 from 90 is 63. But we don't know anything else in these triangles other than this is 27. And this is 33. And this is 90. But we don't know these sides. Now I could say x here and 14 minus x. And you can work it out that way. But let's just use this whole angle and this side. Look at this big triangle and use the law of sines and figure out either this one or this one. Let's just say I find this one. I'll call that x. So x over the sine of the opposite angle equals another side, 14 miles, over the side, the sine of the angle opposite, so that's 120, I believe. 57, so that's 7 to the 63 is 70, and 50 is 120, yes. So I'll multiply by the sine of 33 over here, so I'm going to have 14 times the sine of 33, close parenthesis, divided by sine of 120. That's a special angle, so I should know that, but I'm just going to type it in, and I get x to be 8.8 miles. So now I can use right triangle trig here and get the height. So this is the opposite, this is the hypotenuse. And the sine of the angle is the opposite, the height I want, over the hypotenuse, which is 8.8 miles. And off there. So I'd multiply by 8.8. 8.8 sine of 27. And I get the plane is at 3.995, basically 4 miles high. 3.995 miles high. Okay, so we have harmonic displacement. So let's figure out what this is going to be. So this is going to be the amplitude. And as time goes by, the amplitude is going to decrease. This has a period of 2 pi divided by pi, which is 2. So I'm going to mark off 4 spaces. There's going to be 2, and then 4 more places. There's going to be 4. And that would be 2 periods. So this would be 1, and this would be 3. And at 0 time, this is time, at 0, the amplitude will be equal to this, which will be 3. So I'm just going to say 1, 2, 3, and minus 3. Because e to the negative 0 divided by 8 is 0. E to the 0 is 1 times 3 is 3. And at 1, let's just get some of these here. So I'm just going to make this easy. I'm going to type in here e to the negative x divided by 8. Okay? Oh, times 3. Times 3. And I'm going to go to second table set, start at 0, and go by 0.5. And second table. And so at 0.5, it says it's at 2.8. 2.8. And then 2.6. And then it's at 2.48, almost 2.5. Then 2.33. Then 2.19, it's almost 2.2. Then 2.06. 1.93. 1.81. At 4, yeah. Okay? So I just did that, and I would do the same on this side. Squeezing in. Okay, now the cosine, I've got to do 2 cycles by the time I get to 4. So 1 cycle is going to happen by 2. Cosine will start at the peak amplitude. So 3, and then it's on the center line, then at the bottom, and on the center line, and at the peak, and at the center line, at the bottom, on the center line, and at the peak. So on. Okay. Convert rectangular coordinates to polar. So that's rectangular, that's x and y. So r is the square root of x squared plus y squared. So 49 plus 16 is 41, 54, 5, 65. That's r. And theta, that would be tangent inverse. Tangent inverse of y, 4 divided by negative 7. Negative 29, but since x is negative, I have to add 180. So it's 150.25. 26 degrees. Okay. Now convert this to polar. So y is r sine theta equals 1/2 or 0.5. And x is r cosine theta minus 3. It's converted. Now you can try to solve for r, but you don't have to. Let's say you did, though. So this would be r sine theta minus, getting the r's over here, minus 0.5 r cosine theta. Factoring out the r. And then solving for the r, and r would be negative 3 divided by sine theta minus 0.5 cosine theta. Okay, convert this one. So x squared plus y squared is r squared, and 2x is 2r cosine theta. And you could divide both sides by r, and so you'd get r equals 2 cosine theta. And this one, so this would be our x and y. So the radius, this is a complex, so this looks different. So it's 3 squared plus 4 squared, so that's 9 plus 3 squared plus 2 squared, so it's 9 plus 4, square root of 13. And then you do cosine of the angle, and the angle you would get by doing tangent inverse of y, which is 2, divided by x, which was 3. And that comes out to be 33.69 degrees. Plus I sine of the same angle. And that's how a complex number looks in polar. Now it says find this number, 2 plus 3i to the fifth. So we take the square root of 13 to the fifth. And we do the cosine of 33.69 times 5. And plus I sine of 33.69 times 5. And we would get square root let's see, I got to take this times 5, so I'll do that while I got it there, times 5. And I've got 168.45. And the square root of 13 to the fifth, square root of 13 times square root of 13 is 13. And 2 more would make 169, 13 times 13, square root of 13. And that would be what this is to the fifth, but if I change it back to rectangular, I would have I'll just do it, I'll do it both ways. 169 times the square root of 13, you can see is 609. If I just did the square root of 13 to the fifth, see I get the same answer. So I got to take that times, I'm going to store that in x, so I've got it. And so I'm going to take that number, x, cosine of 168.45, and I get negative 596.99597. And then for the I part, plus I times, what's the sine of this? So I got to do x sine of 168.45, and that's a positive 122.2. Now, just to check my answer, I'm going to type in parenthesis 3 plus 2i to the fifth and see if we get what we had. Pretty dang close. If I had rounded properly, I would have got that. Okay? Convert this to polar coordinates, these polar to rectangular. So I would do That's the magnitude and that's the angle. So I go 10 cosine of 300 plus, and that would be the x, and then the y would be 10 sine of 300. And 300, the cosine is, if I were to do this exact, 300 is down here. Cosine is a half. So half times 5 is 5. Half times 10 is 5. And 10, this is square root of 3 over 2, so that'd be 5 square roots of 3. You can do decimal on it too. And if I want to change this to rectangular, so this is r equals 4 over cosine of theta. I would love to have an r there, or multiply both sides by cosine theta, because I know what r cosine theta is. That's x equals 4. Okay, and I may put some vectors on the test too, since we got into vectors a little bit. All right, and that's the sample test I gave you.